Hello, my dear students. We are going to continue the chapter Symbol Machines. In last class, we have discussed about lever. We have discussed that there are three kinds of lever. They are class 1 lever, class 2 lever, and class 3 lever. In today's class, let us see some more symbol machines and their principles. Here you can see the another kind of symbol machine, that is inclined plane. An inclined plane is a rigid sloping surface over which heavy loads can be raised or lowered to a certain height or depth. A wooden plank kept with one of its edge on a raised object and the other edge on the floor is an example of inclined plane. If a heavy box needs to be loaded on a lorry, it is far easier to push it over an inclined plane than to lift it up. The amount of push depends on the weight of the load and the steepness of the slope. Steeper the inclined plane, greater will be the effort required to push up the load. The mechanical advantage of an inclined plane is the ratio of the length of the inclined surface to the vertical height of the load raised. So, the mechanical advantage of an inclined plane is greater than 1. Therefore, an inclined plane acts as a force multiplier. This means that it can be used to lift heavy loads with less effort. Ramps, roads on hills, and staircases are all examples of inclined plane. Next kind of symbol machine is a wedge. A wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge. The sharp edge is used to cut, slice, or push things apart. A knife, an axe, and a chisel are some examples of wedge commonly used by us. In some cases, the number of inclined planes can be more than 2. When there are more than 2 sloping surfaces, they generally taper to form a very pointed edge. Pins, nails, and needles are some examples having a pointed edge. This is screw, the another kind of a symbol machine. It is a cylindrical rod marked with winding spiral edge called thread. A screw looks like a nail with grooves cut spirally into it. It is actually an inclined plane wound around a rod. The tip of a screw is narrow, sharp, and pointed. The head has a narrow slit which is used to turn the screw using a screwdriver. As the screw is forced and rotated into a piece of wood, it travels a longer distance than a nail would. Less effort is needed to drive a screw into a block of wood than to drive a nail. Also, because of its thread, a screw grips the wood more firmly than a nail. The principle of the screw also applies to a nut and bolt arrangement and a screw jack used to lift a car. A long handle rotates the screw of a jack and the car is raised up. In ancient times, screws were made of wood. Metal screws appeared only about 600 years ago. We will be discussing about the remaining kinds of symbol machines in next class. Till then, take care. Thank you.